Hello everyone. In this video, I am going to discuss a topic on electronic circuits and electronic devices and circuit. My topic is full wave rectifier. A full wave rectifier converts an AC voltage into pulsating DC voltage using both half cycles of the applied voltage. In order to rectify the half cycle input, two diodes are used in this circuit. Diodes fed a common load RL with the help of a center tap transformer. The A full wave rectifier is a circuit which converts an AC voltage into pulsating DC voltage. In this full wave rectifier circuit, we use a center tap transformer. Now I'm going to discuss the characteristics of the full wave rectifier. If I apply full sine wave, if it is during the positive half cycle of the input signal, anode of the D1 becomes positive and at the same time the anode of the diode becomes negative. Hence D1 conduct and D2 does not conduct. The load current flows through D1 and the voltage drop across RL will be equal to the input voltage. Mean during the half cycle of the for an input signal there is both positive and negative half cycle. For the half cycle of the input signal, the anode of diode D1 becomes positive and the anode of diode D2 becomes negative. Then the diode D1 conducts and D2 does not conduct. Then the current flows through D1 and the voltage drop across RL will be equal to the input voltage. During the negative half cycle of the input signal, the anode of diode D1 becomes negative and at the same time the anode of the diode D2 becomes positive. Hence D1 does not conduct and D2 does conduct. The load current flows through D2 and the voltage drop across RL will be equal to the input voltage. Before the input signal is a full sine wave, when it is fully rectified, then the output is only positive half cycle as shown in the figure. Next, there are some characteristics for the full wave rectifier. They are average voltage, average current, RMS voltage, RMS current, peak factor, form factor, ripple factor, efficiency, peak inverse voltage, and percentage regulation. Average voltage. Average voltage is calculated. Average voltage is denoted as VDC. For for us understanding, VDC is equal to formula 1 by pi integral 0 to pi V naught d omega t equal to 1 by pi integral 0 to pi Vm sine omega d omega t. Here Vm by pi minus cos omega t from intervals of 0 to pi. If we simplify that, we get VDC is equal to 2 Vm by pi. If we do that same formula, then average current IDC is equals to 2 Im by pi. Next, RMS voltage. RMS voltage for a full wave rectifier is Vrms is equal to Vm by root 2. And current, RMS current, IRMS is equals to 2 Im by pi. Next, peak factor. Peak factor is equals to peak value divided by RMS value. The peak value of a full wave rectifier is Vm and RMS value is Vm by 2. So peak factor is equal to 2. Next, form factor. Form factor is calculated as RMS value divided by average value. Form factor is equal to Vm by root 2 divided by 2 Vm by pi. That is 1.1. Ripple factor. Ripple factor. The ripple factor of a half wave rectifier is 0.4813 and efficiency is calculated as output power by input power into 100. Then the efficiency of a full wave rectifier is 81.2. Next, peak inverse voltage. Peak inverse voltage is defined as the maximum reverse voltage that a diode can withstand without destroying the junction. The peak inverse voltage across a diode is the peak of the negative half cycle. For full wave rectifier, peak inverse voltage is 2 Vm. Percentage regulation. IDC of Rs plus Rf divided by 2 Vm by pi minus IDC into Rs plus